So can we use these ideas to determine what's going to be in this box of the machine when I drop 27 ounces in? Like, could we predict ahead of time, just looking at the 27, that that box is going to end up empty after all the explodies? So this, we're working on the next box over now. So we got one here and one here. So we have 27 divided by 4, remainder is 3. That tells us that we need to have a 2 ounce, right? So we figured out it's odd, we need a 1 ounce. The remainder being 3 told us there'd be a 2 ounce. So what about this 4 ounce box? Is there going to be a pebble in there or not? Well, we know the answer is there's not.
Divide by 8.
Okay, so if I look at this part of the machine over here, it's going to have a multiple of 8 ounces. So 27 divided by 8 is remainder only 3, which is too light to have something in the 4 ounce box. So when we put our multiple of 8 in these boxes out here, we only have 3 left here. There's not anything that can fit in the 4 ounce box, so that's going to have to be empty. And I could do the same thing. 27 divided by 16 has remainder, I don't have enough fingers, 11, right? Okay, 27 divided by 16, remainder 11. And 11 is really big. That's definitely going to need the 8 ounce pebble to be in there. And then what's left is 16 ounces, so it goes there. Okay, so having gone through all this, I would like somebody to explain to me, I think when we put 27 pebbles in here, we end up with this situation, no matter what. But I could do some other weird things, like, what if instead of putting 27 pebbles in here one at a time, like we just did, didn't somebody ask, what happens if you put like a whole bunch of pebbles in at once, and there's a whole bunch of explosions at the same time? Are we for sure going to end up in this same final position? So like I could say I put 27 pebbles in here, then what happens? There have to be exactly 13 explosions. Aha. Okay, so 13 explosions. I think I'm too lazy to actually draw that many, but you get the idea. Okay, and after 13 explosions, what's left? 1 and 13 pebbles appear here because there were 13 explosions. So now we need to have 6 explosions, okay? And there'll be 1 dot left in here. Okay, so that's the 1 left over in here. This is gone. There's 1 left in there. 6 pebbles will appear in there. 3 explosions, okay. Now I can draw them all. Okay, 3 explosions, and that box is empty, and I get 3 pebbles in the next one. I could write it like that, or I could write it like this, I guess. Only 1 explosion. Oh, is that 1 explosion or 2 when 2 dots explode? Oh no. I guess we're counting that as 1 explosion, right? 1 explosion, but each explosion eats 2 dots. Yeah. I don't know. Okay, and there's 1 dot left, and it makes one pebble there, and that's the end. So how many explosions were there? 23. Is there another way we could figure out that 23 without having to go through all that work? Yeah. We started with 27 pebbles. Each time there's an explosion, what happens to the number of pebbles? 2 blow up. We get 1 new one, so we lose 1 pebble. We ended up with how many pebbles? 4. So to get from 27 pebbles down to 4, there must have been 23 explosions, which we also found by counting them all up one at a time.